Welcome to General Laboratory Safety. This course is required on an annual basis for anyone wanting to do research in a Rice laboratory. At Rice, we have a commitment to keep everyone safe. This includes our graduate students, undergrads, postdocs, and visiting scholars. We also have an obligation to protect our custodial staff. At Rice, we want to develop a culture of safety. This means we think about safety before an accident occurs. As part of developing that culture, Environmental Health and Safety is available to answer any safety questions or concerns. We can be reached at 713-348-4444 or by dialing 4444 from any on-campus phone. We can also be reached by email at safety@rice.edu. During this brief introduction to general lab safety, I want to remind you of a few lab rules. First of all, always wear your personal protective equipment, or PPE. We'll go over in more detail later of what to wear and when. And of course, never bring food or drink into the laboratory. Lab refrigerators and microwaves should be dedicated to lab use only. Next, I want to mention hazard communication. This means being aware of the hazards that are around you. Notice the door sign when you enter the laboratory. This should list hazards associated with the laboratory as well as any important contact information. The number to EHS and Rice University Police Department are also present on the door sign. Be sure to pay attention to any other door signs which would alert you to hazards inside the laboratory, such as biohazards, lasers, or allergens. Another way to increase awareness of hazards is through labeling. You'll want to label everything, including reaction vessels, wash bottles, and carboys. The final way to communicate hazards is through a safety data sheet. These are sheets of information which include hazards identification and should be available for every hazardous material inside the laboratory. Next, we'll go into recognizing the hazards inside the laboratory and minimizing the risks associated with working in a lab. There will always be risks associated with doing laboratory research. However, we want to minimize those risks as much as possible. One way we can do that is by using the RAMP method. RAMP is a convenient acronym that stands for recognizing the hazards, assessing the risks associated with those hazards, minimizing the risks, and preparing for emergencies from uncontrolled hazards. A hazard is a potential source of damage, harm, or adverse health effects on someone or something under a certain set of conditions at work. Some of the chemical hazards that you'll find in a laboratory include oxidizers, carcinogens, and flammables. Other physical hazards that you will find in the laboratory include high and low pressure vacuum equipment, as well as high voltage equipment. Health hazards include not only acute toxins that you'll find in the laboratory, but materials that could cause long-term or chronic illness as well. Risk is the probability of suffering harm from exposure to a hazard. One way that we can assess risk is using a risk matrix assessment. This plots probability versus the consequences of a certain hazard being present. One example that I can give you is working with a low toxicity buffer. On the remote or occasional chance that you might have a splash or a spill, the consequences would be fairly negligible. Therefore, we would consider this to be a low risk activity. Another activity, such as working with a laser with the interlocks disabled, would be more of a high risk activity because on the remote or occasional chance that you had an exposure to the laser, the results would be catastrophic. Now that we've talked about assessing the risk, let's talk about minimizing it. One way to do that is by using a hierarchy of controls. First of all, can we eliminate the risk or the hazard altogether? If not, can we substitute the risk by replacing the hazard with something else? If neither one of those is available to us, can we use engineering controls and administrative controls to help reduce the risk? Once we've used administrative and engineering controls, we should also use personal protective equipment to protect us against the hazards. Three of the controls that I want to discuss more are engineering controls, administrative controls, and personal protective equipment. Engineering controls are going to include interlock devices as well as laboratory ventilation. So let's first talk about ventilation. Laboratory ventilation is designed to contain hazards inside the laboratory. So any spills or incidents in the laboratory should remain inside the laboratory. One means of localized containment is going to be within a fume hood, which is another engineering control. A fume hood is a large box-like structure that's going to have a window on it that opens and closes, and this is called the sash. You should only open the sash as far as necessary to access the work. You should keep the sash closed whenever the hood is unattended or not in use. For more information on proper chemical fume hood use, see our video that's posted online. Another example of an engineering control is an interlock device. These safeguards will shut down an instrument should conditions become unsafe. The second kind of control I want to discuss further are administrative controls. This includes the use of more training and standard operating procedures. Some of the required trainings that you'll need to take are available from the EHS office. This includes general laboratory safety, which of course you're taking right now, biological and bloodborne pathogen safety training, laser safety training, as well as radiation safety training. Another type of safety training that we ask the laboratories to perform and document is laboratory-specific training. Lab-specific training is where when you join a laboratory, you want someone to take you around the laboratory and show you where the hazards are located, where the safety equipment is located, and where you keep your safety data sheets. Another important administrative control is having and using standard operating procedures. You want to use a standard operating procedure anytime extra training is required, as well as extra approval for hazardous materials or hazardous processes. One of the standard operating procedures that we'll talk about today is going to be the procedure for waste collection. A template for standard operating procedures is available on our website. So we're going to talk about what to do with liquid waste, solid waste, and sharps waste. You'll want to collect your liquid waste in a plastic jug called a carboy. You'll notice when you get your carboy from the stockroom that it has a yellow sticker on it. That's for you to tell us a little bit about the waste and how we need to treat it. You'll want to make sure that you segregate your waste based on chemical compatibility. That is, don't mix your aqueous acidic waste with organics. You'll want to keep the cap on unless you're actively filling your waste container, and also put in a waste pickup request whenever you're ready to have it picked up. Laboratory researchers generally have more questions when it comes to solid waste. That is, they're not sure if they can throw away things like paper towels and gloves in the normal waste. The fact is that if gloves and paper towels are only residually contaminated or not really contaminated at all, they can go in the regular trash. However, if you've used your gloves and paper towels to clean up a spill, you'll definitely want to treat those as solid hazardous waste. One special type of waste that we need to talk about are sharps. This is another way of saying sharp objects. These include broken glass, razor blades, syringes with needles, and scalpels. We never, ever, ever throw these away in the normal trash. It could put our custodians at risk whenever they come to collect the trash from the laboratories. For sharps, you'll want to get the proper disposal container from either the EHS office or from the stockroom. For broken glass, that's going to be a sturdy cardboard box with a liner. And for metal sharps, it's going to be a sharps disposal box. The last part of minimizing the risk that we need to talk about is going to be personal protective equipment, or PPE. The first and probably the most important type of PPE that you need is going to be eye protection. When working in the laboratory, you want to be sure and have eye protection on. Whenever you're working in a laboratory of low hazards, most of the time you can utilize safety glasses because they're going to provide impact resistance and some side shielding from splashes. However, if you're working with large volumes of especially corrosive or volatile materials, you may want to get out the chemical splash goggles. For particularly dangerous procedures or when working with cryogenics, you may want to get out the face shield. Normal prescription eyeglasses are not adequate protection. They are not impact resistant and they offer very little shielding against splashes in the lab. I also want to talk about proper laboratory dress code. The dress code for any laboratory environment is going to include long pants or a long skirt and closed-toed shoes. It is best if the entire foot is covered. Also, no sandals or croc-type shoes that have holes in the top of them. When you start working with hazardous materials in the laboratory, you definitely want to have on your lab coat. It'll provide extra protection for your clothing and your arms should anything ignite. Laboratory coats should be worn buttoned up and the sleeves left rolled down for extra protection on your arms. Definitely don't wash your lab coats at home. Have them sent out for a service for proper laundering. When you begin working with hazardous materials in the laboratory, you definitely want to have gloves on to protect your hands. In order to make sure that the gloves that you're using are protecting you against what you're working with, you want to check the safety data sheet of the material you're working with. Also, don't leave the lab with your gloves on. You'll be needing to touch objects such as doorknobs and elevator buttons, and these are objects that other people touch with their bare hands. So if you do need to carry samples in a gloved hand, be sure and leave one hand free for touching doorknobs and elevator buttons. Also, be sure to discard your gloves whenever they're visibly contaminated or if they have a tear in them. And also, don't reuse your gloves. You could contaminate yourself when you try to turn it right side back out after taking it off. The last part of the RAMP method is preparing for emergencies from uncontrolled hazards. These can include fires and explosions, injuries, chemical exposures, as well as fire and medical emergencies. In any medical or fire emergency, you want to call the Rice University Police Department, and you can find them at 713-348-6000 or by dialing 6000 from any on-campus phone. They will dispatch the fire department or ambulance as necessary. In a fire emergency, if you are unable to put out the fire with a fire extinguisher, you definitely want to evacuate the building and pull the nearest fire alarm pull station as you exit the building. This will send a signal to both RUPD and to our office that somebody has reported a fire. If the fire is small enough and you do decide to fight it, use the acronym PASS. That stands for pull the pin on the fire extinguisher, aim the nozzle towards the base of the fire, squeeze the trigger, and sweep the nozzle from side to side until the fire is put out. Remember, never fight a fire larger than a small trash can, and never let the fire get between you and the door. In cases of chemical exposure, you definitely want to get the person to the nearest sink or eye wash station. Give their eyes or affected body part a good rinsing. Rinse, rinse, rinse until emergency medical help arrives. Definitely call Rice University Police Department and let them know that there has been an emergency, and they will dispatch emergency medical help. Please obtain a safety data sheet on the material to give to the emergency personnel. You should notice signs around the laboratory where the emergency eye wash stations and safety showers are located. These areas should be kept clear, and you should be able to reach them in no more than 10 seconds if there is an emergency. I want to mention safety data sheets. Safety data sheets are informational sheets that exist for every material that you've purchased in the laboratory. They include identification of the hazards. They also include first aid measures, in addition to firefighting measures for each of the materials in the laboratory. The flame represents the flammables, and then we have the symbol for oxidizers. The gas cylinder represents gases under pressure. The skull and crossbones represents acute toxins. And then we also have the symbol for long-term health hazards. The exclamation point represents general health warnings. And then we also have the symbol for toxic to aquatic life or the environment. Last, we have explosives and corrosives. After any accident, incident, or near miss in the laboratory, you need to fill out an accident or injury report form. If the person affected is a Rice employee, then we also need the employer's first report of injury or illness. Both of these forms can be found on our website at safety.rice.edu. Thank you for taking part in this General Lab Safety Refresher. Additional information can be found on our website, safety.rice.edu. Here you can learn more specific lab safety regarding chemical, biological, laser, and radiation labs. We also have information for visitors to Rice Labs, as well as accident reporting forms.